Okay, so today in Algebra 2, we are going to be doing section 2.2, which is finding slope and rate of change. And it's important to go ahead and note that slope and rate of change are the exact same thing. So anytime you see a problem that asks for a rate of change, it is also asking for the slope. They mean the same thing. It's just another way of wording it. So if we're finding the slope of a line, whether it's graphed or we know the coordinates, then if we know the coordinates, we're going to use the slope formula, which is m, which represents slope, equals y2 minus y1 over x2 minus x1. So let's just say we have the ordered pair. The set of ordered pairs, negative 1, 3, and 2, negative 1. We want to find the slope of the line that goes through those two coordinates. Then we will use the equation y2 minus y1 over x2 minus x1. And don't let the x's and y's confuse you. Every coordinate has an x value and a y value. So for the first set of coordinates, this is the x value, this is the y value. And in the second coordinate, this is the x value, this is the y value. So in the ones and the twos, I just remember it, the ones that are in the first coordinate, those are the ones. And the ones in the second coordinate are the twos. So maybe that'll help clear up any confusion you may have over which coordinate goes in which location. And then you just plug those into the formula. So our y2 is negative 1 minus our y1 is 3 divided by our x2 coordinate is 2 minus our x1 is negative 1. And then what you do is you just simplify your numerator and your denominator. Negative 1 minus 3 is negative 4. Negative 2 minus negative 1 is the same thing as 2 plus 1, which is 3. And if for your fractional answers, make sure they are in simplest form. So negative 4 over 3 will not simplify. Therefore, that is the slope of the line that contains those two coordinates. Let's have another example of that. So we have the ordered pair negative 2, 0, and the ordered pair 2, negative 4. And we want to find the slope of the equation, or the slope of the line that goes through those 2 points. Again, we'll use the same formula. And again, this is our x, y, x, y. These are the ones. These are the twos. So the y2 coordinate's negative 4 minus y1 is 0 divided by x2 is 2 minus x1 is negative 6. So negative 4 minus 0 equals negative 4. That is the same thing as 2 plus 6, which is 8. And then we reduce our fraction. Negative 4 over 8 is negative 1/2. So negative 1/2, negative 1 over 2, is the slope of the line that contains those two coordinates. Okay, so that's what you do when you have everything that comes out to be just regular numbers, fractions, we simplify them. And then there's a few little special circumstances that happen. For example, these two coordinates. Again, we're going to use the same formula. M equals y2 minus y1 over x2 minus x1. Our y2 in this problem is going to be negative 2 minus our y1 is 5. And our x2 is 3 minus our x1 is 3. So notice I didn't label them that time as I went. But if it helps you to label them, by all means, I do that every time. If that helps you keep them straight, I just omitted that from my steps. All right, so next we have negative 2 minus 5 is negative 7, and 3 minus 3 is 0. And it is mathematically impossible to divide by 0. So we would say that the slope of this line is undefined. The slope of this line, if you divide by 0, it's undefined. One way I remember it is if you're dividing and 0 is underneath, then it's undefined. If 0 is underneath, then the slope is undefined. And we'll talk about what that looks like in a minute. So let's just do one more special little circumstance here. So we have coordinates. negative 2, 6, and 7, 6. So again, we would do y2 minus y1 over x2 minus x1. So in this problem, that would be 6 minus 6 over 7 minus negative 2. 6 minus 6 equals 0. And 7 minus negative 2 is the same thing as 7 plus 2, which is 9. And this time 0 is in the numerator, so it's 0 divided by 9, and 0 divided by any number will equal 0. So let's just talk about what those slopes mean. What those slopes mean. So we have 4 scenarios that can happen when we are getting a slope. So we could have a positive slope. And just a little quick sketch of what a positive slope looks like. We have our x and y axis. And a positive slope rises from left to right. We read graphs like we read words on a page from left to right. So a positive slope is going to rise from left to right. So next we have negative slopes. Negative. So if a positive slope rises from left to right, then a negative slope will fall from left to right. It's going to go down from left to right. Then we have our 2 other special situations. We have undefined slopes, and then we have 0 slopes. So an undefined slope, oops, that's a very crooked line. This crooked also is when we have a vertical line. So the slope is undefined because it is so immeasurably steep that we cannot measure how steep it is because it's perfectly vertical. So an undefined slope is always a vertical line. And then a slope of 0 would be the opposite of that, which would be when we have a horizontal line. It goes from left to right. And it's flat, has a slope of 0. It doesn't rise, it doesn't fall, so that's what a slope of 0 does. So if you have any questions that ask you if the graph has a slope that rises or falls, you can answer it in that manner. Just by if it's a positive number, it's going to rise from left to right. A negative number is going to fall from left to right. If you have an undefined slope, when you have the 0 in the denominator, it will be an undefined slope, which is a vertical line. And if you have 0 in the numerator and the answer is 0, it will be a horizontal line. So the last thing we're going to talk about in this section will be talking about parallel and perpendicular lines. And we should remember from Algebra 1 and geometry that parallel lines have the same slope. It's important. Parallel lines have the same slope. So if one line has a slope that's the same to another line, then those 2 lines are parallel to each other. Well, let's go ahead and note that perpendicular lines let's talk about perpendicular lines. Perpendicular lines are 2 lines that intersect, but it is special. What's special about perpendicular lines is when they intersect, they form 90-degree angles. They form right angles when they intersect. So all lines that are not parallel are eventually going to intersect each other, but perpendicular lines, when they do, they form 90-degree angles. So perpendicular line slopes are going to be negative reciprocals of each other. Some people say opposite reciprocal, which is basically the same thing. I actually like that phrase better. So let's just talk about what an opposite or a negative reciprocal is. For example, if I have a slope that's 2/3, well, the opposite reciprocal of that, reciprocal means that you flip the fraction upside down, so that's 3/2. and the opposite or the negative means you change the sign. So we're going to take the original slope. To get the perpendicular slope, we will find the reciprocal and then change the sign. So what they're going to ask us to do in these problems, I believe this is example E, is they are going to tell us the coordinates for two lines. Line 1, for example, they're going to have negative 2, 2, and negative 1. And for line 2, they're going to give us the coordinates negative 4, negative 1, and 2, 3. So what we need to do is we need to find the slope of both of those lines. And we are going to compare the slopes to see if we have lines that are parallel, lines that are perpendicular, or just two regular lines that will intersect that are neither parallel nor perpendicular. So we're going to use our formula twice for each problem. So again, x2, y2. Again, we're using m equals y2 minus y1 over x2 minus x1. So for line 1 here, we have negative 1 minus 2 over 0 minus negative 2. So negative 1 minus 2 is negative 3, and that's going to be divided by 0 plus 2, which is 2. So negative 3 over 2 will not simplify. So the slope of line 1 is negative 3 over 2. So we're going to do the same thing for line 2. Again, that's x1, y1, x2, y2. And so I'm going to have 3 minus negative 1 divided by 2 minus negative 4. So that makes 3 plus 1, which is 4. And that makes 2 plus 4, which is 6. And that reduces to 2/3. Well, we look in that and we compare that to line 1. So I have the slope of line 1 is negative 3 over 2. And the slope of line 2 is 2/3. And if we notice, if I take the first one and I use the reciprocal and change the sign, I do get this one. So these lines are perpendicular. That means they are going to intersect to form right angles. And just to have one more example of that. So we have a line 1 with the coordinates 1, 2, and 4, negative 3. And a second line with the coordinates negative 4, 3, and negative 1, negative 2. So we have to find the slope of both lines using our formula for slope, y2 minus y1 over x2 minus x1. So for line 1, that would be negative 3 minus 2 over 4 minus 1. And then I simplify that, and I get negative 5 over 3. So there's the slope of line 1. And I'll do the same thing for line 2. I'll say negative 2 minus 3 over negative 1 minus negative 4. Negative 2 minus 3 is negative 5. Negative 1 minus negative 4 is the same thing as negative 1 plus 4, which is 3. And would you look at there? They are the same slope. So line 1 and line 2 are parallel to each other. And that is the end of section 2.2.